Hello, everybody. My name is Massimo Banzi. I'm the co-founder of Arduino, and I'm here to tell you about a low-code approach to secure and productive AIoT application development using Arduino tools and platforms. So first of all, just a quick introduction. I'm going to show you how you could develop an AIoT application using Arduino tools and boards and software that run as a TinyML algorithm to solve a problem that are kind of common right now because of what they call post-COVID applications. So to solve and deal with issues created by this pandemic. So let's just start by looking a little bit at what Arduino is. So Arduino is a hardware development platform, hardware and software development platform that was started now almost 15 years ago with the objective of enabling anyone to innovate by making complex technologies simple to use. So the idea is try to figure out all these parts of the software and hardware development process people have to follow in order to innovate with digital technology and try to figure out how many of these technologies we can take and make simple and understandable for people. So we started off with how to develop simple microcontroller application, and now we are developing tools to make it very simple and easy to do IoT, to do tiny machine learning, to develop on all sorts of different classes of microcontrollers and even Linux machines. So it started off as a very simple sort of project for a very small number of users, my students back in the days, and now it is a very large community. So let's look at some of the numbers of this community. So the Arduino.cc website, which is the main website, is visited by 29 million people every year. So it's a very, very, very popular website. But then there are a very large number of people who also use our platform. So for example, the Arduino forum has over 900,000 people registered. This doesn't mean that there are only 900,000 users. The users are million. Almost 1 million people who are registered are the ones who write and contribute and answer and help people. So it's a very large audience with 1 million people who are engaged in a way. We produce a development environment which is open source, and it's actually used by Arduino hardware, but also a bunch of other bits of hardware by other makers. And that one is downloaded over 17 million times a year. So it is definitely one of the most popular development environments in the world. There's also this Create Cloud that I will talk about a little bit better later, which includes an online development environment, IoT, cloud, and a few other tools. That one has 1.2 million people that are using it, and the number is growing. And just to give you a measure of the kind of software that's available, we have over 4,000 libraries that are available. So for example, any sensor, any actuator, any kind of device that you can interface with a microcontroller, most likely there's a library in Arduino you can just click, install, and use. A lot of them are written by us, and while a lot of them are written by the community or our partners like Adafruit, Sparfan, or Seed Studio, or people like that. So it is a very large community of people that sometimes learn how to program microcontrollers and do embedded development without actually knowing that we're doing embedded development. They just wanted to build something, they wanted to innovate, they wanted to create something, and they didn't have the skills. So with Arduino, they were able to do that very successfully. And you can see there's like literally millions of projects you can find online built with Arduino. And over the years now, we have approached a more professional audience, and this is a little bit more what I'm talking about in this presentation. So one of the big kind of things that we noticed that is Arduino is easy for beginners, but it is fast for professionals. So either people who do embedded development for work, they like Arduino because they can build something really, really quick. But it also enables the people who are professionals in their own field, but are not professional in embedded development. So Arduino as a platform enables those people, maybe somebody who has a company building X product and they want to augment that with some IoT capability, they can do it successfully with Arduino, thanks to the sort of approachability of the platform and the fact that we're very centered on the user experience as opposed to the sort of technological detail of the implementation. So let's look at the application that we are looking at right now. The idea is a lot of institutions right now are facing tasks like how many people are in a room or how many of them are wearing a mask. And sometimes they are constrained by situations where they want and need to guarantee the privacy of people. So they don't want to use any kind of cloud service to do, for example, people detection in the image. So one possible, very interesting application of our kind of technology is to do this kind of stuff using some low power device, which is running this TinyML type of machine learning algorithms that can count faces, can count masks. They can send the data to the cloud, but the data that goes to the cloud is just the number of people. So it's very anonymous. No personal data leaves the device. The device can even run on a battery. So you can actually solve a lot of very interesting problems around this technology. And once the data is on the cloud, using our tools, you can visualize it, you can monitor it, you can connect to other services, and you can also set up trigger alerts. I will show you a little bit more in the rest of the presentation. So let's look at the hardware that we're going to be concentrating on. So the platform that we can use for this kind of project is this new Arduino board that we launched this year called Portenta H7. It is actually one of the most, probably the most powerful microcontroller development board out there because it's got a dual core ARM Cortex processor, which includes a Cortex M7 and a Cortex M4 running at 480 megahertz and 240 megahertz. So it's a very powerful dual core microcontroller board that can have up to 64 megabytes of RAM, 128 megabytes of flash. It's got a crypto authentication element on it, which is very, very important for the connection between Arduino and our cloud to make sure that the authentication is performed in hardware. So there are no sort of easy to guess or to reverse engineer credentials in your code. It's got Wi-Fi, it's got Bluetooth, but it also supports Ethernet, CAN, and a bunch of other protocols through the expansion connectors that are at the bottom. There are over 160 I/O connections that you can use from the high-density connectors. And on top of everything, this thing can run on a battery, so you can use a rechargeable battery that you can charge through the USB-C. The USB-C even has DisplayPort output, so you can even output video from this thing. One of our engineers even ported Doom on it, so you can even play Doom on it if you want to. And everything that you see here is also supported by the ARM Pelion device management client, so you can use this also with the Pelion platform. Coupled with this, we're going to be using this module here, which this is a picture of a prototype. So we are announcing it right now that there's going to be this new hardware available for Portenta, which is called the Portenta Vision Shield. This is a little board that you can basically snap to the back of the Portenta through the high density connector. It supports a couple of high max, low power, but very sophisticated cameras. It's got dual microphones, so you can do beamforming. It supports Ethernet, LoRa. It's got an SD card. So this enables a ton of different use cases where you can do cameras, you can do sound detection, you can use a low power LoRa to send the data, or you can use Ethernet for fast data streaming. So you can implement a ton of different scenarios. So once we have the hardware in place, let's figure out what are the options for us to be able to implement this kind of tiny machine learning algorithms on Arduino. So the classic one is TensorFlow Lite Micro. So this is a version of TensorFlow, the kind of famous library framework from Google. They can take a model developed for the classic TensorFlow and can adapt it to run on a microcontroller. So it is actually quite interesting because you can actually develop your model, the classic sort of TensorFlow platform, and a lot of them would run on a microcontroller. We are running a number of examples of this on a Cortex M4. So on this dual-core Cortex M7, Cortex M4, you can get a lot of mileage out of these algorithms. And you can find a number of examples on our website, also on the platform that you are using to to interact with the conference. You will find a PDF that contains a collection of articles on how to use TensorFlow with Arduino to do tiny machine learning tasks. Another interesting platform is called Edge Impulse. It's a startup that develops this platform that has a very, very interesting user interface, which makes it very easy to develop some of these machine learning tasks. They call them impulses. So the interesting thing, for example, is that you can very easily develop an audio-based impulse. So, for example, it has been used by some users to detect cough. So, for example, detective cough and sneezes can be useful to monitor the situation in place without releasing any personal data to the world. So the very simple user interface allows you to build something very, very quickly and very successful and export it as an Arduino library so you can implement it in your own code. It's called Edge Impulse. Check them out. Another interesting platform is Quixo, which is also compatible with Arduino, which has this feature of providing this AutoML feature. So it is able to kind of develop the algorithm based on the data that you submit. So again, check them out. There are articles that show how to use Arduino with Quixo. And finally, OpenMV. It's a very nice Python-based library that makes it very simple to do computer vision tasks. And there is a version based on MicroPython, which runs on the Portenta. It's compatible with the Portenta. And what you see here in the screenshot is their development environment. So basically, you can edit your Python code. You can get a preview of the camera. So this is running an algorithm that detects faces. And then you can get live data from the camera, but also you can get live data from the algorithm. So for example, with OpenMV, you could very easily develop some of the algorithms that I was discussing at the beginning of the presentation and send the data to a cloud. So check them out. They are also running a workshop. Also, the TensorFlow team is running a workshop in this conference. You really need to go and check them out. Okay, so now when I ran my algorithm locally and I need to go to the cloud, we noticed that a lot of people are still building clouds by themselves, which is crazy. So if you're trying to build an IoT project, the last thing you want to do, you want to also build a custom-made, large, cloud service. So Arduino develops this platform we call the Arduino IoT Cloud, which is based on the idea that everything should be sort of generated and created for you, so you have minimal effort to get something working. So one of the basic things you can do with the Arduino Cloud is manage your devices. We use also Pelion behind the scene to manage devices. We use hardware authentication, so we can, for example, manage the authentication between the device and the cloud through this crypto chip, so that there is practically impossible to fake the authentication of the device, which is a very important security issue. And also we use clean data type. So the data that leaves the device is already, typed with the real data type, so degrees centigrade, atmospheres or any other scientific measurement unit. So you don't have to deal with bytes and unpack payloads and just do everything by hand. It's already typed. It's in the definition of your object. It's very simple to manage. There's also an element of code generation that you will see. So once you've defined your device, you press a button and the system generates the code for your board. You go into this. This is a picture of the IDE online. Basically, everything that's needed for the device to talk to the cloud is already being generated here. So you have to write the code that reads the data from the sensors and connects them to the variable that we provide. Every time you change that variable, the cloud is notified. Every time the cloud wants to do something, it will change variables, it will call methods on your code. But effectively, a lot of the code is pre-generated for you. So you just have to kind of fill in the blank, press the button, put the code on the device, and then you will see the device live in your device manager, sending data, properly connected. You see the hardware associated with your device. And then finally, you can build dashboards, taking properties from different devices and putting them into one dashboard. So for our application, for example, you could be able to pull all these different data from different devices in different rooms, in different spaces, and bring them on a desktop, on the dashboard, so you can actually visualize the situation. So once I've taken all the data securely to the cloud and I'm able to build dashboards and everything else, how can I use this data to build full-blown applications? Well, there's a number of options. One of them is to use the API. So it is very easy to generate a set of API keys so that you can use APIs to talk to the cloud and extract data, communicate with the devices to augment the capability of our cloud. So for example, we provide clients for Python, JavaScript, and Go, but you can also just talk to the REST endpoint, so you can develop in whatever language you want. For example, here I'm showing an example of a Flask Python web application, whereby using this Python client, I can go in the platform, I can take data out that's been sent by the different devices, and I can use it in the application, or I can even send data back. Because our application, our IoT Cloud is not just telemetry, it's a two-direction communication, so you can actually turn on and off things, and you can do all sorts of manipulation with the data. So it's a real-time, bidirectional communication with your devices. So using this API, you can actually integrate the device and the IoT Cloud with a ton of other things that you can either write yourself, or you can use different ways to bridge between APIs. So this allows you to create, for example, a simple web app that a user can use to monitor the number of people in the different rooms that are managed by the system. We also provide a mobile app. So for example, if you created a dashboard in the IoT platform, you can actually authenticate with this mobile app, and you can see this dashboard in a mobile version on your phone. Another thing you can do is that we provide a Node-RED plugin, which has a real-time connection with the cloud. So you can build all sorts of business logic in a visual fashion. You can integrate different services, because Node-RED has hundreds of different bridges to different other products. So you can easily create this in Node-RED. So for example, in this case, I'm showing how I'm taking a property out of the cloud and applying some kind of a business logic to understand if the number of people in a certain room is within a certain range. And then if that goes above, it will send a notification, for example, to WhatsApp. That's a simple business logic to, in a way, notify people that certain threshold has been reached. One interesting thing is that it's very easy to run this Node-RED, for example, on a Heroku platform for very cheap. It's also possible to use Node-RED hosted. There are companies that sell Node-RED hosted online. So it's very easy. It's compatible with this plugin that we developed. Actually, the plugin we developed is in the npm repository, so it's open source. It's very easy to add to your application, and you can build some logic using this technology. So, in a way to summarize, our system, I believe, has a number of interesting properties. First of all, Arduino is committed to open source, so almost everything in what we do is available out there. So the hardware is documented online. You can download files. You can, understand everything about the hardware. Every single bit of software is out there, open source. The code that runs on the Portenta is based on the mbedOS operating system, which is also open source. Then there's a layer on top that implements the Arduino API, open source. All the other libraries like the Cloud, everything is open source. So it is really fast to develop with the Cloud and with the Arduino platform, but you can actually drill down as much as you want into the platform and do whatever you want because everything is open source. So you can actually change everything you want. Also, a lot of the components of the online platform are open source, so you can actually see how everything works behind the scene. So it's really fast to develop things, and you can do that even if your customers don't have a lot of experience in software development. They can actually do it thanks to Arduino. The other thing is interesting I want to bring up is the cost of innovation. So obviously, the speed of innovation, if you can develop very quickly a solution, that's obviously going to be very good for the bottom line. But there's some other interesting aspects that Arduino in a way brings about, which is there are now literally millions of people who have learned how to develop using Arduino. Even people who now went on to study software development, they got masters. A lot of them have started with Arduino. So there's literally, as I said, millions of people who understand the technology, know how to develop using the Arduino API. They've used the platform. So for a company who wants to develop or maybe maintain a kind of platform like this, it is very easy to find resources online that have used Arduino. So it's very simple to find documentation, but it's also easy to find people. So we've been told by a number of the companies we work with, they can easily find people who know how to use Arduino. And some of them might be really beginners, but some of them are actually quite experienced and have actually built real working, functioning devices that are on the market using Arduino. So the platform is very, very popular. So it gives you access to a ton of talent where other frameworks that might be more specialized, more narrow, they will have a lot less users. So it will be a lot more difficult to find people who know it already. So if you want to build something quickly, you want to hire people that are productive from day one, Arduino and its community provide you with that. Also, the cost of ownership, in a way, it's another interesting aspect because, in a way, as I said, the Arduino platforms are open source, left and right. So you own the access to anything that you want. You can look inside, you can modify, you can improve, you can customize. So you're not locked into some very proprietary system that once you use it, they're a prisoner forever. No, you can actually participate in this. You can actually change and improve the platform, or you can even fix bugs if you may find one. And the other thing is that the online platforms that Arduino develops and its hardware are usually very reasonably priced or inexpensive even. So if somebody wants to quickly build a solution that actually works, they can do that with Arduino quickly, they can do it cheaply, and they can run it for cheap. So compared to other platforms that are very, very much more expensive. So in a way, we also provide this reasonable pricing, which I think is very important because there's this large amount of small and medium businesses who don't approach this kind of AIoT applications because they don't understand the technology, they don't have the people, it's too expensive, they don't know where to start. With Arduino, they can start very quickly, they can understand it very quickly, they can find people easy, they can do it for a reasonable budget, and they very quickly can prove that an idea can be a sustainable business model. So I believe that this platform and the work that we have done in the last few years is really taken us from where we started as a sort of simple prototyping platform to something that now has been proven to be a tool that people have used to build real applications that are functioning, that are running machines in factories, that are helping people do real business in the real world. So, and you can do this quickly and simply with Arduino. So that's it for now. I just wanted to give you a lot of pointers and basically give you a different perception of what people understand about Arduino. So thank you very much for joining us. Thank you for attending the presentation. If you have any question, we are now available. Thank you very much.